Welcome all. Today we are going to learn more about S block elements. What are S block elements? S block elements comprises of basically two groups of the modern periodic table, that is group 1A and group 2A elements. Group 1A, you can see it is लीना के रब से फरमाइश, which is lithium, sodium, potassium, rubidium, cesium and francium. Whereas group 2 elements are B mug का सरबरा, that is beryllium, magnesium, calcium, strontium, barium and radium. In this chapter, we are going to learn about the characteristic properties of the S block elements, variation in properties of the S block elements, variation in properties of the S block compounds, uses of compounds of the S block elements. Let's see one by one. Which characteristic properties of S block elements are we going to learn? We are going to discuss about the metallic character, low electronegativity, basic oxides, hydroxides, ionic bond with fixed oxidation states, characteristic flame colors, weak tendency to form complexes. So what is metallic character and how we are going to define? As we know, the elements that can lose an electron and acquire positive charge, they are termed as metals. Now group 1 elements have high tendency to lose electron to form positive ions, as its electronic configuration is ns1. Hence, metallic character increases down the groups. Metallic character increases down both groups means for group 1 as well as group 2 elements. Now, as we are moving down, why the metallic character will increase down the group? As we are moving down the group from top to bottom, electronic configuration increases. That means the atomic number increases, which increases the number of atomic shells in a group, and hence the atomic size of a particular element increases as we move down the group, due to which the nuclear force of attraction between the valence shell electron and nucleus decreases. Hence, it's very easy to remove one electron from the valence shell. Hence, metallic character increases down the group. Electronegativity. What is electronegativity? Electronegativity means the element attracts the shared pair of electrons towards itself. Hence, low nuclear attractions for outer electrons, as these elements are highly electropositive, and hence it will have the small electronegativity down the group. Now, when we are talking about the oxides of group 1 and group 2 elements, we are saying that these oxides are basic in nature. Now, why they are basic in nature? This we have already proved the relations in grade 10th while learning acid, bases and salts, where we have learned that acid plus base gives salt and water. Similarly, when acid plus metal oxide reacts with each other, again it proves salt and water. Hence, we came to the conclusion that metallic oxides are basic in nature. Next is, that is, metallic oxides dissolve in water produces metallic hydroxides. Now, hydroxides are also basic in nature. Therefore, we can say metallic oxides are basic in nature. Therefore, group 1 and group 2 element oxides are basic in nature. That is why we have termed they are basic oxides as well as hydroxides. Now, group 1 and group 2 elements can also form oxides, peroxides as well as superoxides. But again, some exceptional cases are there. Now, oxide means having oxygen -2 valency, whereas when we are talking about peroxides, at that moment, the valency of oxygen is -1. Whereas in superoxide, the valency of oxygen is -1/2, that is -0.5. And as you can see within exceptional cases, lithium does not form peroxides or superoxides due to its smaller size. When we are talking about hydroxides, all hydroxides are soluble and they are basic in nature. That we can see that as we move down the group, the basic strength increases, right? But in group 2 hydroxide also solubility increases from amphoteric to basic and basic strength increases down the group. Next, when we are talking about its electropositivity and ionization enthalpy, at that moment we do talk about its oxidation state. Group 1 elements are most electropositive metals. Now, why they are the most electropositive metals? As they have ns1 electronic configuration, which shows that it has only one electron in its s orbital. Therefore, it's easy to remove one electron and acquire positive charge. Therefore, they have a low first ionization energy. Now, what is ionization energy? The energy required to remove an electron from a neutral gaseous atom to acquire a positively charged ion. Hence, we can say for group 1 element, it has low first ionization enthalpy and extremely high second ionization enthalpy, because after removal of one electron, that is from ns1, it becomes ns0. Now, which is attaining its stable electronic configuration, or we can say octet configuration. Let's take one example of sodium. Sodium atomic number is 11. Therefore, its electronic configuration is 281. Now, as we are removing one electron, after removal of one electron, sodium becomes Na plus ion, which contains 2,8 electrons. Now, as you can see here, it contains 2,8 electrons. That means it has completely filled outer orbital, which is undergoing the octet configuration, or we can say noble gas configuration. Therefore, the second ionization energy is extremely high. And group 1 element has fixed oxidation state, that is of +1. Whereas when we are talking about group 2 elements, it has low first ionization enthalpy and second ionization enthalpy, but very high third ionization enthalpy. And it has a fixed oxidation state of +2. Beryllium and magnesium compounds possess some degree of covalent character. Next, when we are talking about the characteristic flame colors, so group 1 and group 2 elements give characteristic flame. Here we have taken one example of sodium. Now, why these give rise to characteristic flame? As they are moving from lower energy level to higher and then getting back to higher to lower. In between, they give a color. So here we go for the flame test, and the specific flame color is been noted over here for group 1 element as well as for group 2 elements. Next, when we were talking about that group 1 and group 2 elements have weak tendency to form complexes. Why it is so? As S-block metal ions have no low energy vacant orbital available for bonding with lone pairs of surrounding ligands. They rarely form complexes. Now, this kind of complexes can be seen for the D-block elements, which are also coming under the metals. But what kind of metals? They are termed as transition metals. Whereas group 1 is known as alkali metals as they form the soluble bases, and soluble bases are known as alkalis. Hence group 1 element have got the name alkali. Whereas group 2 elements are known as alkaline earth metals because most of the metals hydroxides are found in the earth crust. That is the reason why group 2 elements are known as alkaline earth metals. Variation in properties of elements. Now, which type of variations and where the variations we are going to check? That is atomic radii. Ionization enthalpy is due to the variation in the atomic radii. What changes we are going to see in the properties? Ionization enthalpy, hydration enthalpy, melting point, and reaction with water, oxygen, hydrogen, and chlorine. Let's see one by one. Now, what is atomic radius? Atomic radius is the distance measured between the valence shell and the nucleus of that particular atom. So that is what your atomic radius. Now, as you can see, as we move down the group, the atomic radius is increasing. You can see that lithium, sodium, potassium, rubidium, cesium, and francium, we have increase in atomic radius down the group. As with increase in atomic number, the number of shells also increases, and hence we have a drastic change in atomic radius. But here in case of rubidium, cesium and francium, you can note the changes, it's little bit small as atomic number increases, so number of shell increases, and then it again have the D configurations, right? So they do face electron-electron repulsion and this greening effect, and due to this you can see we do not note much atomic radius difference between cesium and francium. Next, similarly, you can see that atomic radius of group 2 element is less than that of group 1 element, because as we move from left to right in a periodic table, number of electron increases in the same shell, which increase the force of attraction between the nucleus and the valence shell and results in decrease of atomic radius. But down the group, you can see the trend is same, that is with increase in atomic number, down the group, atomic radius is increasing. Ionization enthalpy, as we have already discussed about the ionization enthalpy, that what is ionization enthalpy. So these are the following trends of group 1 element for ionization enthalpy. That is, they have generally low first ionization enthalpy as it is well shielded from the nucleus by inner shell. Next, removal of a second electron is much more difficult because it involves the removal of inner shell electrons. Third point, that ionization decreases as the group is descended. That means as we move down the group, ionization energy decreases with increase in atomic size and atomic number. Right, this is due to atomic radius increases and the outer electron is farther away from the well-shielded nucleus. So this is what the variation of group 1 elements, as well as I have tried you to show the difference of the periodic elements as well, moving from left to right with increase in atomic number. So we have noted the different variation of ionization enthalpy. So this is what the group 2 ionization enthalpy, that is the first ionization enthalpy, second and the third one. Now as you can see, as we are moving down the group, the first ionization energy decreases down the group. Similarly, the second ionization energy is more because if we take an example of magnesium, magnesium atomic number is 12. Hence, its electronic configuration is 2, 8, 2. Now, when we are talking about 2, 8, 2, but ionization enthalpy means removal of one electron at a time. Therefore, it removes one electron at a time. When after removing one electron, it becomes Mg plus 1. Now, to remove the second electron, we need to apply more energy because the decrease in the atomic radius. And third has to be the most one because after removing the second electron, then Mg attained its noble gas configuration, that is 2, 8. Hence, it requires lots of energy to remove the third electron. You can see the graph for the ionization enthalpy of group 1 element as well as the group 2 elements. This is the ionization enthalpy graph moving from atomic number 1 to atomic number 18. And as you can see here, helium, neon and argon has the noble gases configurations which have the high ionization energy than the rest of the elements from 1 to 18 atomic number. These graphs are very important. From this, the MCQs are asked. Next, ionization enthalpy for group 2 elements. It has low first and second ionization energy. Ionization energy decreases as we move down the group. And ionization energy of group 2 is generally higher than the group 1. So that is the main comparison, that is ionization energy of group 2 is higher than the group 1 because group 1, as we move from left to right, so left to right, moving from left to right, we have group 1 and group 2 elements. Next comes hydration enthalpy, which is also known as hydration energy. Now the layman language, hydration means the addition of water or intake of water. Hence, hydration enthalpy is the amount of energy released when 1 mole of ions undergoes hydration. Right, I repeat, hydration enthalpy means the amount of energy released when 1 mole of ions undergoes hydration. Therefore, hydration energy is one component in the quantitative analysis of solvation. Right, basically why we say solvation? Solvation means addition of solvent. Now, water is the universal solvent. Right, hence it is particular special case of water. So here M plus gas means metal. M means any metal of group 1. M plus aqueous gives M plus aqueous plus heat. The heat energy that is released, it is your hydration enthalpy. So this is the way how hydration enthalpy graph goes for group 1 and group 2 elements. That is, it decreases down the group. Hence, we can confirm that hydration enthalpy decreases down the group. These are the general trends of hydration enthalpy. That is, on going down both the groups, hydration enthalpy decreases. Now, why it is decreasing? Because the ion gets larger. Now, as the ion gets larger, the charge density, that is the electron charge density of the ions decreases. The electrostatic attraction between the ions and water molecules gets smaller. Hence, the energy released will be less. Similarly, group 2 ions have hydration enthalpy higher than group 1, as we have discussed for ionization enthalpy as well, because group 2 ions are doubly charged and have smaller sizes. Next characteristic properties that we are going to talk about is melting point and boiling points of group 1 and group 2 elements. Now what is melting point? The substance, the temperature at which the substance starts melting is known as its melting point, whereas the temperature at which the substance starts boiling, that means liquid to vapor, it is known as the boiling point. Now, as you see down the group elements, group 1, Lina ke Rabse, right, francium, why we are not taking? Because it is coming under the radioactive element. So they are highly active elements, so we cannot judge about their physical properties. Now, Lina ke Rab se farmais, the melting point of cesium is very low, and hence this is the element which melts at your room temperature, at your palm. If you hold the cesium right in your palm, it will start melting. Hence, the melting point of cesium is very low. Now you can see the boiling point as we go down the group, the boiling point also decreases. Similarly, when we are talking about the melting point of group 2 elements and boiling point of group 2 elements, but here in this case you will see some variation, right, increasing, decreasing. Now why this is so? That is, this change is taking place because of its electronic configurations upon the stability. The melting point depends upon the crystal lattice. Let's check on what basis this melting and boiling point shows the variation. That is, the strength of metallic bond depends. Variation in melting points shows variation due to the strength of metallic bonds. Now, strength of metallic bond depends upon the ionic radius, number of electrons contributed to the electron C model per atom, as well as the crystal lattice structure. The exceptionally high melting point of calcium is due to the contribution of d orbital participation of metallic bonding. You can just compare one more time. Here you can see the calcium is having the high than the magnesium. And why beryllium is so high? Right, beryllium is so high because beryllium, right, it is having a smaller size and it is having a diagonal relationship. It shows anomalous behavior than the group 2 elements. I hope this is clear. So this is what the variation in melting point due to its lattice structure. As we were telling about what is lattice structure, it is a proper arrangement of an atom which gives the proper bonding, right? As you can see, we do have a proper structure of water molecule as well, right? So these are the various structures related to the elements. Now these structures we are going to study in grade 12th in chapter solid state chemistry, right? Lithium shows BCC, means it is body centered cubic structure, whereas HCP means hexagonal close packing structure. CCP means cubic close packing structure. Next, we are going to learn about the chemical properties.